Tech Talk topic isomorphic bijection of cube graphs. Name Shyam Kumar, roll number 2195 section ITV, subject DMS, discrete mathematical structure, second year, third semester. Isomorphic bijection of cube graphs. Graphs partially are the dividing of a graph into two or more parts based on certain conditions arises naturally throughout discrete mathematics, and problems of this kind and have been studied extensively in the 1990s and conjugulated that the vertices of every cubic graph can be partitioned into two parts that induce isomorphic subgraphs using probabilistic methods. Together with delicate recoloring arguments, we prove endos conjugate for large connected graphs. Graph isomorphism. Generally speaking, in mathematics, we say that two objects are isomorphic if they are the same in terms of whatever structure we happen to be studying. The symmetric group S3 and the symmetry group of an equilateral triangle D6 are isomorphic. In this section, we briefly discuss isomorphism of graphs. Connected cubic graph counting. I want to count the number of connected and disconnected cubic non-isomorphic graphs with vertices to n, but I haven't been able to come up with an algorithm or technique to do so. So I have been researching for the past 2 days and haven't found anything convincing. Technique I will try is converting the graph to adjacency matrix and looking for pattern using combinatorics, two-color theory, and so on. I know the sequence of connected cubic groups for 2, 4, 6, 8, 10, 12, 14, and so on to n vertices as 0, 1, 2, 5, 1985, 509. Graph theory enjoys application to a wide range of disciplines because the graphs are incredibly flexible mathematical structures capable of modeling very complex systems. The study of complicated network model following important questions. So, to what extent can be a graph decomposed into smaller subgraphs? Spearheading these lines of research is the classic problem of a graph coloring, one of the oldest branches of graph independent sets as possible. Indeed, subgraphs cannot get much simpler than independent sets, but such ambitious goals come at a cost. Not only is the determination of a graph chromatic number a neutrally difficult problem, but even when you're dealing with space graphs classes, one can require many colors. For instance, many deregular graphs cannot be partitioned into much fewer than independent sets. Isomorphism. Isomorphism in modern algebra a one-to-one correspondence mapping between two sets that previous binary relationship between elements of the sets. For example, the set of natural numbers can be mapped onto the set of even natural numbers by multiplying each natural numbers by 2. The binary operation of adding two numbers is prevalent, that is adding two natural numbers and then multiplying the sum of by 2 gives the same result as multiplying each natural number by 2, then adding products together, so the sets are isomorphic for condition addition. In symbols, let A and B sets will be element and bm respectively. Furthermore, let plus and 2 indicate their respective binary operations. Because an isomorphism previous preserves some structural aspect of a set of mathematical group. It is often used to map a complicated set onto a simpler or between better known set in order to establish the original set's properties. Isomorphisms are one of the subject studied to group theory. In mathematics and isomorphism in a structural reversing mapping between two structures of the same type that can be reversed by an inverse mapping. Two mathematical structures are isomorphic if an isomorphism exists between them. The word isomorphism is derived from the ancient Greek equal and morphon form or shape. The interest in isomorphism lies in the fact that two isomorphic objects have the same properties. Thus, isomorphic structures cannot be distinguished from the point of view of structure only and may be identified in mathematical jargon. One says that two objects are same upon two isomorphism. An automorphism is an isomorphism from a structure to itself. An isomorphism between two structures is a concordional isomorphism. If there is only isomorphism between two structures, or if the isomorphism is much more natural than otherwise isomorphism. For example, for every prime number, P all fields with P elements are canonically isomorphic with a number unique isomorphism. The isomorphism theorems provide canonical isomorphisms that are not unique. The term isomorphism is mainly used for algebraic structure. In this case, mapping are called homomorphisms, and homomorphisms is an isomorphism if and only if it is bijective. In various areas of mathematics, isomorphisms have received specialized names depending on the type of structure under consideration. For example, an isometry is an isomorphism of metric spaces. In a homomorphism is an isomorphism of topological spaces. A diffeomorphism is an isomorphism of spaces occupied with a different structure, typically differentiable manifolds. A semi-peloton morphism is an isomorphism of symmetric manifolds. A permutation is an automorphism of a set. Geometry isomorphisms and automorphisms are often called transformations. Category theory, which can be viewed as a formalization of the concept of mapping between two structures, provides a language that may be used to unify that approach to these different aspects of the basic idea. Applications in algebra, isomorphisms are defined for all algebraic structures. Some are more specifically studied. For example, linear isomorphism between vector spaces. They are specified by invertible matrix. Group isomorphisms between groups. The classification of isomorphism classes of finite groups is an often open problem. Ring isomorphism between rings. Field isomorphism are the same as ring isomorphism between fields. Their study, and more specifically the study of field automorphism, is an important part of Galileo's theory. Just as the automorphisms of an algebraic structure from a group, that isomorphisms between two algebras sharing a common structure. For a heap, letting a particular isomorphism identity the two structures turn this leap into a group. Thank you.